Hi. Albedo is the measure of how much of the incident radiation that hits a surface is reflected. So I have here a shiny white surface. Most of the light that hits it is reflected. It has a high albedo. It reflects a high percentage of the light that hits it. This surface is the opposite. This has a low albedo. Most of the light that hits it is absorbed. It doesn't reflect very much. Okay, so when I say how much, I'm talking about percentage. Albedo is a measure of the percentage of the light that is reflected from a surface. So a high albedo surface reflects most of the light that hits it. Now, this is important in climate. We have two very nice shiny white surfaces, one at each end of the globe, right, the North and South Pole, and they reflect a heap of the incident solar radiation. So if the greenhouse effect is like a little blanket keeping us warm, the poles are our air conditioner. They keep us cool. They reflect a lot of the light that comes in. Now, if they weren't there and this was just water, there's a lot more energy that would be absorbed and not reflected. So the polar ice kind of waxes and wanes throughout the year. In winter, the ice caps get further south. Well, this is the North Pole. In the south, they get further north. Get further south, and then they shrink and get smaller. They get larger. They get smaller, and that happens every year. There's also, in geological time, the ice goes further, and we have ice ages and interglacial periods and ice ages and interglacial periods. Those are caused partly by the way the Earth moves around the sun, that the shape of the orbit changes and can cause the ice ages. So when the ice is frozen, there's a much larger surface reflecting the heat, and when the ice melts, there's a smaller surface reflecting less heat. So as you will know, the ice caps have been melting more recently than they have over hundreds of thousands of years. So new bits of ice are melting now that haven't melted for hundreds of thousands of years. How do we know that? Ice cores. So they've taken ice core samples. They know how long that ice has been there by looking at the carbon dioxide fingerprint in the ice cores, like I showed you a couple of weeks ago. So when the ice melts, sea levels rise, and when the ice freezes, sea levels drop. So as the ice melts, the sea levels will rise, and there is this concern, not just with sea ice, that when the sea ice melts, sea levels will rise, but when the glaciers melt, glaciers is the ice that's on the land, when that melts as well, it's causing sea level rising, which is what's happening at the moment. And I know there's some oil tycoons sitting in Albedo saying, where's my oceanfront house you promised me 10 years ago? But there's also a lot of Pacific Island nations saying, oh dear, my feet are getting wet. So the sea levels are rising, and they're starting to see it in some of the Pacific Islands. So as the ice melts, it's replaced with darker water, which is absorbing more heat, which adds to the temperature of the Earth, which causes more ice to melt, absorbs more heat, turns into more water, which absorbs more heat, more ice melts, and so on. It's a self-perpetuating cycle that scientists are afraid that once it's started, it's going to get out of control. We're going to lose the ice caps, we'll have higher water levels, and we'll also lose part of our cooling system that will add to the increased temperature of the Earth. So that's how what albedo has got to do with climate in the ice. Now, water in the ocean is a little bit different. The Earth is 70% ocean. So that little bit extra water, I don't know how much more heat that's going to absorb, because water has this incredible ability to absorb loads and loads of energy without itself getting hot. So then it can release that energy maybe at night time without itself getting very cold. So water is like this buffer that keeps the Earth at a very stable temperature by absorbing lots of that heat without actually heating up itself. So I've got a picture here for you. There it is. This is the Amazon rainforest, and I want to show you how albedo works over here. So you've got the dark area where a lot of heat's being absorbed, and it gets very warm there, and it's very warm, and there's a lot of water in the rainforest, so you end up with a lot of evaporation and transpiration from the trees, which means clouds form, and then it rains, and then it's hot there because it's absorbing a lot of heat, so it causes evaporation, and then it causes rain. And the Amazon rainforest creates its own rainfall because of the albedo that it has, because of its low albedo. So it would rain, it would be a lot cooler in these parts than in the rainforest. And it rains a lot more in the rainforest because the rainforest is dark. So at the moment, the Amazon rainforest is disappearing. The numbers I see are like 20% of the Amazon rainforest has disappeared in the last 50 years or something. But I think the last couple of years there's been loads of burning, and I think the number might have gone up a little bit higher. And then if there's not enough dark areas to absorb water to make rain, it will start to dry out. And I'll show you another picture. Not that one, hang on, further up. There it is. See this little section of Western Australia. This little line here is the rabbit-proof fence. Now, when the farmers decided to use this, come in here, they pulled out a lot of jarrah forests from in here. This was all jarrah forest and some of it karri forest. And the farmers, the people came through and they cleared the jarrah forest, and they said, look at this great stuff. Look at all this timber. We'll build houses. We'll build, railways. We'll build boats, whatever. And they cleared the land. And then, of course, it had been a nice rainy area. So farmers moved in and went, let's grow our crops here. And all of a sudden it stopped raining. And on the east side, and I can't, the screen's frozen, so I can't do anything here. On the east side of the rabbit-proof fence, it still rains. But on the west side, where the farms are, they don't get as much rain. Now, there's another photo I want to show you, but my screen's frozen. So, and it's just of an aeroplane. You're looking out of the aeroplane across the rabbit-proof fence, and there's all clouds forming along the forest on the east side, and then nothing on the west side. And now there's problems with drought on the farms down there. So when we change the albedo of the land, we change the climate. All right, so that's albedo and climate. And I can't remember what's next, but maybe I'll be back.